5. The origin of space bodies. The bulk of the mass contained in the suns and planets of a superuniverse originates in the nebular wheels. Very little of superuniverse mass is organized by the direct action of the power directors, as in the construction of architectural spheres, although a constantly varying quantity of matter originates in open space. As to origin, the majority of the suns, planets, and other spheres can be classified in one of the following 10 groups. 1. Concentric contraction rings. Not all nebulae are spiral. Many an immense nebula, instead of splitting into a double star system or evolving as a spiral, undergoes condensation by multiple ring formation. For long periods, such a nebula appears as an enormous central sun surrounded by numerous gigantic clouds of encircling ring-appearing formations of matter. 2. The world stars embrace those suns which are thrown off the great mother wheels of highly heated gases. They are not thrown off as rings, but in right and left-handed processions. World stars are also of origin in other than spiral nebulae. 3. Gravity explosion planets. When a sun is born of a spiral or of a barred nebula, not infrequently it is thrown out at a considerable distance. Such a sun is highly gaseous, and subsequently, after it has somewhat cooled and condensed, it may chance to swing near some enormous mass of matter, a gigantic sun or a dark island of space. Such an approach may not be near enough to result in collision, but still near enough to allow the gravity pull of the greater body to start tidal convulsions in the lesser, thus initiating a series of tidal upheavals which occur simultaneously on opposite sides of the convulsed sun. At their height, these explosive eruptions produce a series of varying-sized aggregations of matter, which may be projected beyond the gravity reclamation zone of the erupting sun, thus becoming stabilized in orbits of their own around one of the two bodies concerned in this episode. Later on, the larger collections of matter unite and gradually draw the smaller bodies to themselves. In this way, many of the solid planets of the lesser systems are brought into existence. Your own solar system had just such an origin. 4. Centrifugal planetary daughters. Enormous suns, when in certain stages of development, and if their revolutionary rate greatly accelerates, begin to throw off large quantities of matter, which may subsequently be assembled to form small worlds that continue to encircle the parent sun. 5. Gravity deficiency spheres. There is a critical limit to the size of individual stars. When a sun reaches this limit, unless it slows down in revolutionary rate, it is doomed to split. Sun fission occurs, and a new double star of this variety is born. Numerous small planets may be subsequently formed as a byproduct of this gigantic disruption. 6. Contractural stars. In the smaller systems, the largest outer planet sometimes draws to itself its neighboring worlds, while those planets near the sun begin their terminal plunge. With your solar system, such an end would mean that the 4 inner planets would be claimed by the sun, while the major planet Jupiter would be greatly enlarged by capturing the remaining worlds. Such an end of a solar system would result in the production of 2 adjacent but unequal suns, one type of double star formation. Such catastrophes are infrequent, except out on the fringe of the superuniverse starry aggregations. 7. Cumulative spheres. From the vast quantity of matter circulating in space, small planets may slowly accumulate. They grow by meteoric accretion and by minor collisions. In certain sectors of space, conditions favor such forms of planetary birth. Many an inhabited world has had such an origin. Some of the dense dark islands are the direct result of the accretions of transmuting energy in space. Another group of these dark islands have come into being by the accumulation of enormous quantities of cold matter, mere fragments and meteors, circulating through space. Such aggregations of matter have never been hot and, except for density, are in composition very similar to Urantia. 8. Burned-out suns. Some of the dark islands of space are burned-out isolated suns, all available space energy having been emitted. The organized units of matter approximate full condensation, virtual complete consolidation, and it requires ages upon ages for such enormous masses of highly condensed matter to be recharged in the circuits of space, and thus to be prepared for new cycles of universe function following a collision or some equally revivifying cosmic happening. 9. Collisional spheres. In those regions of thicker clustering, collisions are not uncommon. Such an astronomic readjustment is accompanied by tremendous energy changes and matter transmutations. Collisions involving dead suns are peculiarly influential in creating widespread energy fluctuations. Collisional debris often constitutes the material nucleuses for the subsequent formation of planetary bodies adapted to mortal habitation. 10. Architectural worlds. These are the worlds which are built according to plans and specifications for some special purpose, such as Salvington, the headquarters of your local universe, and Uversa, the seat of government of our superuniverse. There are numerous other techniques for evolving suns and segregating planets, but the foregoing procedures suggest the methods whereby the vast majority of stellar systems and planetary families are brought into existence. To undertake to describe all the various techniques involved in stellar metamorphosis and planetary evolution would require the narration of almost 100 different modes of sun formation and planetary origin. As your star students scan the heavens, they will observe phenomena indicative of all these modes of stellar evolution, but they will seldom detect evidence of the formation of those small, non-luminous collections of matter which serve as inhabited planets, the most important of the vast material creations.